Hello and welcome to another episode of Carbohydrate Discussion Series. Today, Abhishek will present Thioglycoside Preactivation via instant Sulfenyl Chloride generation. Let us begin the session.
Good morning to everyone. I'm going to present this OL organic letter paper, user-friendly thioglycoside reactivation via instant sulfenyl chloride generation. This paper by this Zhong and Zhang. Let us discuss in a concise way what this paper are about. Uh, Thioglycoside reactivation enables one-pot oligosaccharide assembly but relies on unstable sulfenyl chloride activators. They report a user-friendly manifold that forms sulfenyl chloride in second from common thiols and N-chlorosuccinamide, with succinamide precipitating and a clear supernatant serving as a drop in activator solution. The protocol tolerates the substrate scope, accommodating special stereoselective glycosylation reaction and iterative one-pot sequences. A concise These papers also mainly focus about this concise synthesis of a human milk tetrasaccharide demonstrate rapid one-pot access to a biologically relevant motif. As this streamlined oligosaccharide assembly by thioglycoside preactivations, starting from thioglycoside by preactivating with this para-toluene sulfonyl chloride, and these two moieties, one is either alpha OTF or this oxacarbonamide will be formed, which after glycosylation with taking as an acceptor to form this disaccharide thioglycoside, with which after iteration to convert into oligosaccharide. There are some merit as well as demerit about these reactions. Merit are these are one-pot synthesis and automated synthesis, and demerit are about unstable activators and have a tedious operation. Coming to this work, user-friendly version, starting from para-thiotoluene by reacting with N-chlorosuccinamide, taking a DCM solvent at room temperature for 1 minute. This instant para-toluene sulfonyl chloride formation. As we can see that from this figure, these are the para-thiotoluene. After adding this N-chlorosuccinamide, the color suddenly changes in 1 minute. There are two moieties are formed. One is this supernatant, and this succinamide is going to precipitate out. Then starting from this thioglycoside, which is activated by silver tiflate at minus 60 degrees Celsius, and the reaction left for 10 minutes. Then whatever this supernatant is formed is going to add at minus 60 degrees Celsius, and again this reaction left for 15 minutes. Then finally, reaction with acceptor at minus 60 degrees Celsius to room temperature, further disaccharide is going to form. This slide talks about this glycosylation of glycoside acceptor. He varying only this acceptor by taking as a constant donor. The reaction condition is a para-thiotoluene, NCS, DCM as a solvent for 1 minute, then adding this silver tiflate in the presence of moglasives. Then further minus 60 degrees Celsius to room temperature by taking as a DCM solvent, corresponding disaccharide is formed. In this, they talk about the acceptor by taking it as first sugar alcohol, then with some aliphatic alcohol, as well as this, they also try with phenol nucleobase acceptor. If we talk about this sugar alcohol, if we look closely, all this compound, they are varying only the protecting group, and in all the cases, he got a very good amount of it, like 98%, 89%, 80%. But in 3H, 3I, and 3J, in this case, he got comparatively less yield as compared to this before one, with the 65, 71%, and 77%. And what he mentioned is that as in all these, there are protecting group benzalidine as well as propylidine. And he mentioned that because of this peering acid release from the acceptor, the less is going the yield is going to affect. And he also mentioned is that this can be mitigated by addition of proton scavenger like TTBP. And in this aliphatic alcohol, in this case also he got a very good amount of yield, as we can see that from 99, 96%, 97%. They tried this and maintain this 5-member NBOC group with the menthol. In all cases, he got a very good amount of yield. Then finally, he also tried with some phenol nucleobase acceptor. As we know that these are not very good acceptor like this phenol, this nitrogen lone pair is conjugation. In all cases, this acceptor is not good, not very good, but still they are getting a very good amount of yield with the beta only stereoselective product with a 95%, 88%. And this is only because of like pre-activated method, that what he want to mention in that paper. Then he also varying the donor as well as acceptor. Like he studied this acceptor scope studies as well as donor scope studies by changing the acceptor, by changing the linkage, as well as like they are trying with C6, C3 as well as C4, C3. In all cases, they are getting a stereoselective beta only product with a very good amount of yield. And in the donor scope studies, if you look that this 5N, 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 and this 5O, in this 5N and 5N cases, here alpha product, selectively alpha product is formed. As usual, this because of antimeric resistance, because of this C2, alpha is going to form. But by changing this C2 to OBN, by like C2 OBJ to OBN, here he got stereoselectively beta only product, and this 5O is went by this transition state as a direct displacement SN2 type reaction. So he got in this case beta only. Then finally he changes, he places in situ position two group like this DNNH and BCN. This is the DN group and this is a BCN group. So in this DN group, he got selectively beta with 81% yield, and it is because of this strong strong electron withdrawing group. In this case, oxocarbenium ion is disfavored. That's why it's going by this mechanism like direct displacement SN2 reaction. However, in this case, in 5Q cases, this CN is going to like there is hydrogen bonding with the acceptor. That's why there is a oxocarbenium ion will be formed, and this nucleophile is going to attack from below side. That's why here alpha product is formed. And finally, in this paper, they talk about they synthesize this human milk oligosaccharide HMOs. Human milk oligosaccharide are abundant bioactive glycans in human breast milk that shape infant health, influencing metabolism, neurodevelopment, immunity, and inflammation. They are built from the 5 monosaccharide glucose, galactose, glucanac, fucose, and neuromic 5 acetate that combine in diverse linkages to give more than 200 structure. If we look at this streamlined synthesis of human milk tetrasaccharide by instant para-toluene sulfonyl chloride, this thioglycoside 6 was activated with para-toluene sulfonyl chloride, then followed by addition of this thioglucoside 4C to form thiolactoside, which was then again reactivated by this 6-azidohexanol, which is going to cap this reducing end to form this disaccharide with the 93% yield. And then by reaction with DDQ, in DCM solvent, which is going to deprotote this naphthyl to form this as an acceptor. Then parallelly 6 was activated and glycosylated with this 4H and this crop protected amine, which then by the reaction with this acceptor, whatever they prepared in this first one part glycosylation to form this tetrasaccharide, which after reaction with AOH and by global deprotection clip synthesize this human milk oligosaccharide compound. And also they mentioned that these are the from 6 to 10. This is a one pot without intermediate solution and without purification. Like from 6, he got 10 compound with the 43%. In both one pot sequences, all linkages were installed with a complete beta selectivity through anchimeric resistance. Finally, base-mediated trans-esterification and installation of the amine, followed by global hydrogenolysis of BN-naphthyl and benzalidine group, with the concurrent reduction of the azide afforded the target human milk tetrasaccharide with a 62%. Collectively, this sequence highlight the operational simplicity, stereo control, and compatibility of our pre-activation platform for rapid access of human milk oligosaccharide. And summary of this paper is that they have stabilized an operationally simple pre-activation platform that simplifies access to the sulfenyl chloride activator by the instant generation of activator from readily available thiols and NCS within seconds. The method exhibits broad donors and acceptor compatibility, tolerance, diverse protecting group, and anomeric thiosubstituent, and support a successive one-pot sequence to streamline the formation and accommodated to construct special glycosiding linkages as exemplified by 1,6 manosilation and 2,6 glucosylation. The concise synthesis of a representative human milk tetrasaccharide showcases stereo control, efficiency, and complementarity with chemoenzymatic routes to HMO. They anticipate that the simplicity, speed, and versatility of this approach will facilitate access to well-defined glycans at a scale, thereby supporting chemical glycobiology, mechanism-driven studies, and therapeutic discovery. Thank you.
Nice presentation, Abhishek. Go to the page, slide 5.
Yeah.
Actually, I didn't understand what is SR1 and SR2. Actually, I don't have.
What is
SR1, SR2?
SN1, SN2?
No, SR1. Yes, RR.
This.
Like
there's this thiotoluene, thiophenyl somewhere. Like here, he wearing this R1, R2.
That's what I'm telling. So why the one SR1 is reacting and SR2 is not reacting like that?
Why SR1 is reacting, SR2 not? I didn't understand your question.
Yes, SR1. Both are donor, right? Donor and acceptor.
These are donor and acceptor, huh?
So what is R1 and R2? That's what I'm asking. Here, for example, R2 is in first example thiotoluene.
Like,
Second example
and
thiophenol. What is R1? R1. They prepared that. Go to previous slide. Okay, for example, here thiotoluene, right?
Thiotoluene, and here
thiotoluene is a donor and other things are acceptor.
Acceptor, he wearing only acceptor.
Yes.
But
so in the presence of NCS,
here they are wearing both, like a donor as well as acceptor. So this R1 is a thioglycoside, what I understand, and this R1 like they are wearing toluene as well as phenyl, I think.
So why it is not going to the self glycosylation like with the same compound?
Arun, they
Abhishek,
are using same only. That is pre-activation they are showing, right?
yes,
Oh, then it's fine. Then it's fine. Reactivation if they are doing.
Go to your
paper
previous,
itself is
the first slide.
Oh, that's not.
Before this.
title. Go to title.
Here.
Here also they are showing once this R1 is activated, then only
Okay.
after 10 and
Okay.
15 minutes this acceptor they are adding, and now there is nothing to activate the next thioglycoside.
Okay. 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 Then got it. Got it. Yes.
Content is there. Already it is activated. It is
Mhm.
ready for coupling.
Then there is no problem. Yes.
So whatever this second acceptor thioglycoside will be there, that they are using later if they have to make trisaccharide and all again.
Yes. Yes. Yes.
So this whole concept is of pre-activation only.
Pre-activation.
Then it's
Right.
fine. Yes.
They are keeping this only. They are showing this with C2 participation only. Is there any select? Go to the next slide. So here they have shown with some OBN, C2 OBN protecting group. There also they have got this beta product because of Bengaluru protection. But what in this 5Q?
C2BN. Like all are in all cases, C2 is OBZ.
Where is C2OBN you are telling?
This
C2 OBZ.
5O, the last line donor scope study we have shown, right?
Here.
All are OBN, right? Where is
No,
Oh,
here,
okay,
here
sorry.
OBN. Like
But that
by
is seed manos, na?
That is very well known because of Bengaluru they are getting.
Yes.
So what they are explaining here in donor scope study?
here like this OBZ, because of anchimeric resistant, alpha is formed. But by replacing OBZ with OBN, so here he got only beta 1. So they are explaining that it is a direct displacement reaction happen like SN2. That's why here beta is formed.
Okay, that is okay. But what in 5P, the below
5P, here like this C2 is DN and here C2 is BCN. So here what he was saying that because of electron withdrawing group of this C2, oxacarbenium ion is very unfavorable. It's not forming. So that's why this nucleophilic attack is a direct displacement reaction happen. While in this BCN group, because of hydrogen bonding with this acceptor, this oxacarbenium ion is formed, and then this is going to attack like by alpha attack.
So in these cases, they have shown only one example with these donors.
With he take a strong electron withdrawing group and this BCl to show that how it form beta and how it form alpha.
If that is the case, I am wondering like they could have used the same protecting group instead of using BZHC2, and they could have done the complete this scope studies with some more acceptors. Okay.
And still what I feel is the substrate scope or stereoselectivity, it is a like general concept. It's not like particular for this one. Since they have used this one, they're trying to explain why this one is like. I don't think so. I don't see very much novelty in this donor scope. Like if you see maybe NHDNS or NHDN, they might all be explored already. Since they're getting everywhere, they're getting beta, here they're getting Y alpha, they're trying to explain with the previous data, I think.
Yes.
Mm.
Correct. Maybe.
And also, like, this is like, what is that? They did The whole paper concept is, if you see the title slide, instead of using a thiophenol, there means paratolulyl thionyl sulfur chloride is there, na. Instead of that, they're generating in situ since it is unstable activator.
Well,
That
they
is
are
the
going for
novelty.
one
You go to
process.
previous slide. This one. Next slide.
This one.
Next you go. Next. This one. If you see, the table A is already known. Table B is whatever they have done is, instead of using the sulfenyl chloride is unstable. So they are generating that activator in situ. That is the novelty of this reaction. That's it. Like all this pre-activation using thionyl sulfenyl chloride, all are reported only. Their thing is they're generating in situ because that is an unstable activator to maintain outside.
So in this reaction sequence, whatever they are showing, they have taken this their thioglycoside with SR1, and then
Yes.
they are adding silver triflate at
Yes.
minus 50 degrees Celsius.
And
Then
they
after 10 minutes, they are adding this supernatant.
supernatant, whatever they prepared before.
At 10 minutes,
Yes.
they are adding,
Huh.
and at minus 60 only. And then after 15 minutes of that, they are adding the acceptor.
Acceptor, right.
Containing thioglycoside, thiomoiety, but then they will leave it to come to room temperature, and in that process, it is getting coupled.
Just with the silver triflate, sulfur will not activate, na?
But from
Maybe
this
maybe
sequence, whatever we can make out, whenever this temperature is going from minus 60 to room temperature, then
yes.
only the reaction is happening.
Okay.
So if that's the case, then another acceptor is also there. So the supernatant they are adding, like they are adding one equivalent only, they are calculating it.
I don't think so.
Like,
Supernatant they are adding to the reaction mixture itself.
no, they are adding supernatant by drop wise, whatever, like here they are showing now. So this succinamide is going to precipitate out, and whatever the compound is top, they are adding by drop wise.
They
It's
mentioned
like
like they added dropwise.
They mention in that I read that people, they are adding by drop wise.
So it's like we are making the promoter system immediately and we are using.
Means separately making and adding to the reaction mixture.
Okay.
And I think that this supernatant here, this sulfur bond is going to form. Means
Correct.
Disulfide bond.
they didn't mention about the mechanism of this reaction, but what I think that by
No.
adding this,
What I'm telling you is this activation is there na paratolulyl sulfonyl chloride that must be established by someone or that group may itself. So that's why they didn't mention much of about these things here.
Okay. So like after adding the supernatant, this sulfur bond is formed, right?
Yes,
Okay. Yes. Okay. Got it.
Then after this adding acceptor, this glycosylation is happening.
Okay, so till.
But I didn't understand what in this 10 minutes gap is there after adding silver triflate to till adding the supernatant, just that silver triflate and glycoside. What is happening at that time then?
That displacement is happening at that stage only, maybe at minus 60. The complete whatever they are telling SN2 or SN1 substitution, that is not happening. Or maybe hexacarbenium annual form, that is also not going under full conversion.
Okay. And I don't know, just made a very basic question. Like the silver has means like without NIS using any silver triplet or TMSO triplet, can thio be activated? No, right?
I think that silver is helping to remove this chloride, right?
That is after adding the supernatant, right?
Hmm.
I'm just having the doubt what
This
happens in the
was
first 10
okay.
minutes.
It's first step, no?
Hmm. Because generally I don't know. That's why I'm asking like, is the any say TMSO triplet, silver triplet can activate the thio donor?
No, it cannot activate, but it will be there. The moment they are supernatant adding, immediately triplet will be available, silver chloride will go out, and this that counter cation anion will be there, and then this thio whatever intermediate will form.
That I understood. Why they are leaving it 10 minutes after adding silver triplet? Until you are adding the supernatant, whatever that this one, until that silver triplet will not have any role. So why they are waiting for 10 minutes? That concept I didn't understand.
I feel like this is just representation because the
Hmm.
arrow is not like after 10 what they have added. The way of mechanism is first the toluene sulfonyl chloride will come and this anomeric sulfur will attack. Then that sulfur will
Okay.
become disulfonium ion. And then
Okay.
they will add silver triplet. Then only the reaction will form, like proceed. And it will for sure form the oxocarbonium ion. And after that, since the completely this donor is getting activated, that will take
Hmm.
hardly 10 to 15 minutes. After that, they
Hmm.
are adding the acceptor. It's the proper mechanism only. It's not like they are adding first silver triplet. No, first they are adding this pre-activated this toluene sulfonyl chloride.
Okay.
And also, if you see like next step also where they are explaining the mechanism alpha. So that means it's forming the like oxocarbonium ion, and then the
Hmm.
triplet is stable in the alpha in the beta yes in the axial form. So that's why
Hmm.
now axial phase is blocked, and then that's why they're getting the beta in the benzaldehyde case because there will be a strong anomeric effect in the 5N and other two cases.
Benzene, in the last cases, yes,
That
yes.
is already yes known.
That's what I'm telling. There is no much novelty in this relation. That
This
method
there is no
itself is like
novelty,
the.
and also this sulfonyl chloride is very much stable. Otherwise, it's not like it's unstable. But they wrote in the first block A, right, is unstable. That's why they are
Yes, yes,
preparing the
that's
in
what their
situ.
whole agenda of paper, right? It's
And
unstable,
also
unstable.
the pre-activation is done by using NIS. Also, people have done just use pre-activation of using NIS. Then after that, acceptor has been added, and then reaction is proceeding with the normal
Okay,
mechanism.
okay.
Abhishek, I have just one out in the last slide. I feel like second last.
This one.
So if you see after the removal of the acetyl group, they have used acetylation in methanol. It's possible.
Yes, here.
First step.
Ah.
Acetylation in the methanol is not possible here. It will directly form acetic acid and the methyl
where
acetate.
they have done acetylation methanol.
Here.
And talk
First, after this reaching in case
Then,
cross
of
removal.
that is then, right?
Huh?
Oh, okay. Got it.
No.
Acetic
After
anhydride and methanol.
uh, and then finally they removed the BN group, and then they used SCl and the methanol. Then again the whatever acetylation happened for the OH group, then that will again be protected.
reprotect. Right.
But this escalation, whatever they have done the first step, that is not possible, I feel like.
If acetylation is that much easy in stick methanol, instead of pyridine, you could have used methanol only for our reactions and all.
It's not possible. Yes, it will instant react with the acetic anhydride. It's like
Then it
kind
was
of
methyl
acid
ester.
reaction. It instant it will form acetic acid. It's exothermic reaction, a very fast reaction.
But like here mentioned that this base mediated transesterification and then installation of the amine.
That's what
And
I'm
that's
telling.
fine.
And
That is.
that's what I'm asking. That
Hmm.
addition of the amine is not possible in the methanol. It's fine. Okay, we'll check it. Because if you do, sometimes we quench the acetic anhydride by using methanol also,
And what is forming?
Okay.
There only acetic anhydride, methanol. Okay, acetic acid.
Yes, that is one of the way we can evaporate acetic anhydride,
Yes.
na?
Not evaporate,
Mhm.
we are quenching. Yes, exactly. That is the methyl ester that will easily go. Now, so come to previous slide, 6th slide or 5. Okay, in case of BCN, so there is a hydrogen bonding with the CN group. That's why it's
That's
coming
why.
in axial way. It's forming alpha only.
Mhm.
So in this case, triplet has the like contact and pair, not the covalent bond.
Uh-huh.
And rest other cases, triplet was with the covalent bond. Okay, Abhishek, I'm done.
Then there is no any further question. Can I stop?
Yeah, good presentation, Abhishek. I don't
Okay.
have question, so we can stop.
Okay. Thank you.
If you enjoyed this session, don't forget to like, share, and subscribe. We'll meet you in the next episode, next session. Thanks for watching.